In this video, we're going to talk about some common errors and pitfalls that you might run into when you use numbers. So first one, undeclared, uninitialized variables and unused variables. Let's take a look at that. Undeclared or uninitialized variables and unused variables. So here I'm declaring a double called interest rate, and I'm assigning 0.05 to it. And then I'm declaring a double called interest, which is going to be the result of the calculation of taking interest rate times 45. What's the error that we're going to see there? Okay. First of all, interest rate was never declared because the variable was called interest rate with a capital R, which is the right way to name the variable. Okay. So interest rate with a lowercase r is not the same variable. Now, if you were just using Notepad to edit your Java, you might not see that, and you might try to compile it and have problems. Since we're using a pretty good editor, it's going to detect this variable and tell you before you ever compile it that you haven't declared that variable. So watch it. Depending on what editor you're using, you may or may not catch it before compile time. Error 2, integer overflow. I have an int. 2,147,483,647, which is the highest number that an int can hold. And I add 1 to it, and I get negative that number. It's a big number. 2,147,483,648. It becomes negative. It's something to do with binary math. And it causes an integer overflow. Basically, this number gets too big. If we look at it in terms of ones and zeros, it ends up having one more digit than it's allowed to have. The extra digit gets cut off, and Java stores negative numbers in a specific way because of the sign, and something called 2's complement and 1's complement will cause this error because the extra bit got truncated off of this. So anytime you store a number that's too big for the type, and you can do it by doing a calculation by accident, you'll get an integer overflow in this case, and that's not a valid number. That is not one more than this. It's like 4 billion less than that. So you'll see that error. The math can come later. If you want to understand how the binary math works, I could go through that with you. But just know this happens when you try to store a number that's too big into an int. Or any other type for that matter. If you try to do something that's too big for the type, you're going to get overflow errors. The next common error we can end up seeing is round off errors. So here's an example. We're printing out 1 minus 0.1 minus 0.1 minus 0.1 minus 0.1 minus 0.1, or 1.0 minus 0.9. Let's actually try that. I can show you what happens. When it does this, we would expect 0.5, but we get 0.5 with a bunch of zeros and a 1 after it. Because of rounding errors. So it's important if we're doing calculations like that, that maybe we round off to a couple decimal points. We'll look at techniques for that in future chapters. Or in this case, 1.0 minus 0.9, we would expect to get 0.111, or excuse me, 0.1, and we end up getting 0.099999998. If we rounded that to a single decimal point, we'd get the right answer. Even if we rounded it to 2 or 3, we might get the right answer. Or rounding it at all, because these would all round up to 0.1. So watch out for those errors, those rounding errors. They can add up and cause some calculation problems. Unintended integer division. I think I've hammered this one home several times. We're trying to do something with integers, and in this case, number 1 plus number 2 divided by 2. This is an integer. Number 1 plus number 2, they're integers. The result is an integer. We divide it by an integer. The answer is going to be an integer, even if we store it in a double. So this, since This will be 3 divided by 2. You would think it would be 1.5 as the average, but it doesn't come out to that. It comes out to 1 because this is integer division. So it was unintended integer division, and we lost all the decimal points. Even though we ended up storing it in a double, it did all the calculations over here as integers before it stored it over here as a double. It automatically converted it and put a 0.0 on it, but not until it was too late. Okay, so unintended integer division, we've talked about it several times now. We did it with the temperature conversion thing, and I hinted at it in even earlier videos in the last chapter. Watch out for that. That's a pretty common one. Here's one that I see new programmers do a lot. Redundant input objects. So I create a new scanner, and I tell the user, please enter an integer, and I say input. That's the name of the scanner I created right here. Get the next integer, and I store that in a variable called v1. And then I make another scanner. This time I call it input 1 because I can't use the same variable name, and I make another new scanner out in memory. And I ask input 1 to get me the next double and store it. Well, it works. The thing is, that scanner, we don't need to make 2 of them. Okay, you only ever need to make 1 scanner. We can ask the same scanner. I can say input.nextInt, and later on I can ask this original scanner input. I can say input.nextDouble, and it will go get the next double. It still exists. I don't have to create a new scanner every time I ask the user for a value. That scanner can be reused as many times as we want. So don't make multiple scanners. You should only need 1 in your program to get input from your users, and you can call on it as many times as you want. Input.nextInt, input.nextDouble, input.next, which we haven't talked about yet, but we'll see later. Okay, so don't make multiple scanner objects. Don't make redundant input objects. All right, that's the end of the common errors, common pitfalls that we see, especially with new programmers, things that you should watch out for as you're programming.